Hi, I'm Richard, and welcome to this video where we will be exploring the question of what good data looks like in Excel. It's an important question to ask because when you work with data, the quality of your outputs are quite often dependent on the quality of your inputs. And understanding what clean data looks like to input into that process is critical as a result. We're going to explore this from a Microsoft Excel perspective for a couple of reasons. Firstly, Microsoft Excel is easy to display on the screen and gives us nice tangible examples that we can use to discuss. And secondly, it's where most of us actually start our data journeys. It's certainly where I started my data journey several years ago. But having said that, just because we're using Microsoft Excel to answer this question of what clean data looks like, it doesn't mean that this video is limited to people who only work with Microsoft Excel. If you work with data frames in R or similar things in Python, this video will be highly relevant, and the concepts we introduce will be relevant to you regardless of the data program you work with. There are three learning objectives for this video. First of all, we're going to discuss what clean data is. Secondly, we're going to understand why it matters. And thirdly, we're going to introduce tidy data as a framework for describing what good quality clean data should look like. Let's start by exploring what clean data is. Clean data can be best defined by saying it is data that requires no additional transformations, no additional cleansing activity, or no additional work prior to the commencement of analysis. Quite simply, it means we're given data and we can start on the interesting analysis work straight away. Now, in the world of data, that's far from the norm, and we're often given what is called messy data. And messy data is the opposite of clean data. It requires some form of cleansing activity or some form of transformation prior to being able to start work on the analysis. This is best explored with an example. The example you can see on the screen is a collation of a number of individuals' exam results. This data set would be best described as messy. And the reason for that is we can't even answer simple questions such as what is the average exam score from this data set without putting some effort in to clean and transform this data into a better state. So if we just have a look at some of the issues we've got here, we've got exam scores in differing formats. So we have 62% here, we have 0.915 here, which should be interpreted as 91.5%. We have 87 out of 95. We have a written response of 80%. We've also got inconsistent formats here. So you can see over here for person A, there's a number of spaces between person and A. Now that may or may not be important for the analysis, but it is inconsistent with the other results. And we've also got one random person, person G, over here in column E on the data. This data set is messy. If we want to analyze this data, then we are going to have to put some effort in to clean it. Now that naturally poses the question, what does a clean instance of this data set look like? Well, if we flip over to the next tab on this data set, we can see a clean instance of this data set. We'll explore exactly why this is a clean data set a bit later in this video, but there's a few things to note from this. So first of all the values for all the exams are in the same format. We've got 3 decimal places in here, so we can interpret this easily as a response. And it also means that we can calculate answers or ask questions of this data easily. So we can calculate the average score of the respondents in this exam pretty easily by using the average formula, and we get 75.2% pretty quickly. This would be a clean version of this data. The next question to explore is, why does clean data matter? And we've already alluded to some of the answers to this question in this video so far. Clean data matters because it is essential for completing the analysis that has been requested of us. We need good quality, clean data to drive good quality analysis. We've also seen a few examples of why clean data is needed that are specific to Excel. So, for example, the average function would only take numeric values as an input when we had data that said 80% in text. This function wouldn't recognize that. Pivot tables in Microsoft Excel also work with tabular data. The data needs to be organized in columns, it can't have any breaks, and every column needs to have a name. They just won't work unless the data is in that format. It's also important to have clean data so that we can guarantee the accuracy of the data. It is much easier to spot errors in data where there are consistent formats applied and we know what we're dealing with. If you look at the data set from earlier, it would be much easier to spot a missing value or an inconsistent value in the second data set compared to the first. But the other reason why clean data is important is that as data analysts and as people who work with data, we can spend an extraordinary amount of time cleaning data. In fact, it's estimated that up to 80% of a data analyst's time can be spent cleaning data. So if we understand what good clean data looks like, we have a chance to influence the activities that capture that data at source and reduce the effort needed to clean it later down the line. The final question we are left pondering is, what does clean data look like? And it's a question that in 2014 a data scientist called Hadley Wickham found themselves pondering. Despite the considerable amount of effort that his colleagues were putting into cleaning data, he found that there was very little written about the standards that clean data should adhere to. This led him to develop the tidy data principles, 3 simple principles that help us describe what good quality clean data should look like. Before we go on to introduce those, we're going to need some definitions. The first definition we need is that of an observation. An observation is a collection of all the data that we are interested in for an individual instance of something we are looking at. So let's say we're looking at individual people. All the data we have for person A would be an observation. All the data we have for person B would be an observation. And all the data we have for person C would be an observation. The next definition we need is that of a variable. And a variable is a feature that we can measure about an observation. So for example, it could be an individual's height, or it could be their shoe size. You'll also hear of variables referred to by the names of features or attributes, particularly in the world of data science. The final definition we need is that of a value. A value is the individual specific measurement for an observation and a variable. So for example, a shoe size of 11 would be a value. A height of 185 centimeters for observation A would be a value. Having defined values, variables, and observations, we can now go on to state the tidy data principles. And as we alluded to earlier, these are 3 very simple statements. First of all, each value is its own cell. Secondly, each variable is its own column. And finally, each observation is a row. This can easily be explained if we consider the example from earlier where we're looking at 3 individuals and have collected their height and shoe size. Let's capture this data in a tidy format. If we work backwards through these principles, the first thing to note is that each observation should be a row. So all of person A's data is in row 1, all of person B in row 2, and all of person C's in row 3. The variables we've collected, the height and shoe size, they will be columns in this tidy data set. And then the values, the individual measurements for each observation and each variable would be cells. We can also see from this very simple tidy data set something that would be considered best practice as well, that the values within each variable are all of the same data type. Now if we go back to the example from earlier, we can now articulate why this would be a clean data set. It is clean because it adheres to the standards of a tidy data set. Each observation is its own row, so each individual exam score is its own row in this data. Each variable is its own column, and each value is its own cell. We can also see in this example that all of the exam scores are of the same data type. They're a 3-point decimal number. The tidy data principles give us a very powerful method for explaining what clean data should be. 3 very simple statements. Each value is a cell, each variable is its own column, and observations are rows. That brings us to the end of this tutorial on what clean data should look like in Excel. In it, we've explored what clean data is, we've explored why clean data matters, and we have introduced the tidy data principles as a framework for describing what clean data should look like.